welcome to the 3.0 questions. I know you're excited. Sorry, just adjusting the volume here. All right. Pretty basic. We covered these in class, but, sometimes you like to double check. I'm going to only be showing the exact answers here. You can check the answer key for for the decimal approximations. Also, I'm going to generally, like I've said, done in class, use natural log for everything. So if you wrote down log instead of natural log everywhere, I have a natural log, you have a log, you're good to go. Okay. So first one, exponential terms for all the 3.0s are already going to be isolated, so you don't have to worry about that. You can take the log of both sides. Exponent is going to move out front. If it is an add-in, a difference or add-in type of thing, make sure that you put parentheses around them. At this point, you have two different options. I am fine with you. I will do both. Actually, you know what? I'm just going to rewrite it over here. I'll do what we've been doing in class first because that will work in every situation. I'll show you the second one in a second. You distribute out the natural logs. You move over the non-variable part. And then I'm going to divide through by natural log of 5. So x is going to equal natural log of 15 plus, stupid, silly, what do you call it, calibration. And you get this. No, you may not divide out the natural logs of 5s unless you split it into two separate fractions, which is what you're going to actually see over here. This generally works best if you only have variables on one side of the equation before you do the distribution. If you wanted to, I could divide both sides through by natural log of 15. This does not turn into the natural log of 3. Don't even think about it. And then on the right-hand side, or left-hand side, you get x minus 2. So I'm going to add 2 to both sides. So x is going to equal the natural log of 15 divided by the natural log of 5 plus 2. Now notice, if I compare that answer to the first one over here, I basically did one fraction like this. So that's the natural log of 15 over 5. And then the other side of this is taking 2 natural log of 5 over natural log of 5, and then the natural log of 5s will drop, and that's where you get the plus 2. Okay? We'll call it the Noah-Watkins rule, since he's the one who likes doing that. Hey, shout out to Noah. Congratulations. All right. So for this one, same idea, same thing, pretty basic. Actually, you know what? Since they're all basically the same, let me double check these. I'm going to do this one because this one's a little more complicated. The second one, you can check your answer. It's the same process. Natural logs. Why? Because they're natural. And everybody knows natural things are better for them, right? That'll be the no reason to do natural logs. So that, you get natural log of 5. If you want to divide both sides through, go for it. I'm not going to. Why? Because I said so. So natural log of 1/4 minus 4 natural log of 1/4 is equal to natural log of 5. And then from there, all right, so then from here, move all the non-variable stuff. So 3p natural log of 1/4 stays. Quick thought that some of you might be having going through your heads. If you broke down natural log of 1/4 into natural log of 1 minus natural log of 4, the natural log of 1 would turn into a 0, which potentially could make, sorry, brain cramp while I'm trying to talk, could potentially make some of this a lot simpler. I'm not going to expect you to do that right now. So divide everything through here. I'll explore that in a second just for grins, because I know some of you guys will care. Some of you guys can just go ahead and turn it off. So I get P is equal to the big natural log of 5 plus 4 natural log of 1/4 divided by 3 natural log of 1/4. And we can double check other options out on the answer key. What I was talking about before, let me grab what I want up here quick. Let's grab this. Oops. New page. Hello, paste. All right. You could potentially at this point here, so you're going to get 3p minus 4 times the quantity. Change this into the natural log of 1 minus the natural log of 4. Now, if you take the natural log of 1 on your calculator, think of it this way. What exponent do I put on an e to make it equal to 1, right? Natural log of 1 is going to be the same thing as e to the 0 power is equal to 1, so that's going to equal 0. So this essentially disappears. So now I get 3p minus 4 times natural log, just the opposite of the natural log of 4 is equal to natural log of 5. And that kind of cleans up everything kind of nicer. And then you would continue to go yada, 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 yada. And that would at least save you from having the 1/4 in there. Just a thought. Anyway, that's the 3.0s. Again, the second problem, you can model it off the 2 that we just did. And check out the 5s. If you have questions or concerns, yell, scream, kick, come in early, and we'll see you tomorrow.